LangGraph implements dynamic execution control through interrupt-driven state persistence, enabling human-in-the-loop validation at arbitrary points in workflow execution. The framework's checkpointing mechanism serializes graph state to a durable store, while the interrupt function surfaces payloads to external systems via the interrupt field, creating a bidirectional communication channel that maintains execution context across suspension and resumption cycles. We'll examine how this artifact establishes a tool approval pipeline by instrumenting a LangChain tool with interrupt logic, configuring state management through SQLite persistence, and demonstrating the resume protocol using thread-specific identifiers. The implementation showcases how conditional execution paths emerge from interrupt payloads while maintaining state consistency across suspension boundaries. Import SQLite 3. From typing import type dict. From LangChain, tools import tool. From LangChain Anthropic import chat Anthropic. From LangGraph, checkpoint, SQLite import SQLite saver. From LangGraph, graph import state graph start end. From LangGraph, types import command interrupt. Class agent state type dict. Messages, list dict. At tool. Def send email to. SDR subject, SDR body, SDR. Send an email to a recipient. Hash pause before sending. Payload surfaces in result interrupt. Response equals interrupt. Action, send email. To. Subject, subject. Body, body. Message, approve sending this email. If response, get action equals approve. Final to equals response, get to. Final subject equals response, get subject, subject. Final body equals response, get body, body. Hash actually send the email, your implementation here. Print send email to equals final to subject equals final subject body equals final body. Return F, email sent to final to. Return, email canceled by user. Model equals chat Anthropic model equals Claude Sonnet 4-5-20,250,929. Bind tools send email. Def agent node state, agent state. Hash LLM may decide to call the tool. Interrupt pauses before sending. Result equals model. Invoke state messages. Return messages, state messages plus result. Builder equals state graph agent state. Builder, add node agent, agent node. Builder add edge start, agent. Builder, add edge agent end. Checkpointer equals SQLite SQLite 3. Connect tool approval, DB. Graph equals builder. Compile checkpointer equals checkpointer. Config, configurable, threaded, email workflow. Initial equals graph invoke. Messages. Role, user, content. Send an email to email protected about the meeting. Config equals config. Print initial, interrupt, hash interruptful u equals action. Send email. Hash resume with approval and optionally edited arguments. Resumed equals graph invoke. Command resume equals action. Approve, subject, updated subject. Config equals config. Print resumed, messages, -1 hash tool result returned by send email. This code demonstrates a human-in-the-loop approval workflow using LangGraph's interrupt mechanism. The pattern shows how to pause execution at critical points, allowing external review and modification of tool calls before they execute. The send email tool uses interrupt to pause before sending, surfacing the email details in the interrupt field for review. When resumed with command resume equals, the tool either executes with original or modified parameters or cancels entirely. The implementation leverages SQLite checkpointing via SQLite saver to persist state between interruptions, with threaded acting as a persistent cursor.
This approach enables durable workflows where approvals can happen asynchronously. The agent node processes messages and may invoke tools, while the interrupt mechanism ensures no action occurs without explicit approval. This pattern is particularly valuable for sensitive operations where human oversight is required, though it adds complexity to the execution flow. The design choice to place interrupts within tools rather than nodes makes the approval logic reusable across different graph structures. However, this requires careful handling of side effects, as nodes restart from the beginning when resumed. The example shows how to handle both approval and cancellation cases, with the interrupt payload allowing parameter overrides before execution. This creates a flexible approval system that can be adapted to various workflows while maintaining safety through explicit human confirmation. Let's break it down.
Import SQLite 3.
Imports SQLite 3, Python's built-in library for interacting with SQLite databases, enabling database operations like creating, reading, updating, and deleting records in SQLite database files.
From typing, import typed dict.
Imports typed dict from the typing module, which enables creating dictionary types with specific key value type annotations for static type checking.
From LangChain, tools import tool.
Imports the tool decorator from LangChain's tools module, which is used to define functions as tools that can be invoked by agents or other components in the system.
From LangChain Anthropic, import chatAnthropic.
Imports the chatAnthropic class from the LangChain Anthropic module, providing access to Anthropic's chat model functionality within the LangChain framework.
From LangGraph, checkpoint, SQLite import SQLite saver.
Imports SQLite saver from LangGraph, checkpoint, SQLite, which provides SQLite-based persistence for saving and restoring graph execution state during interrupts.
From LangGraph, graph import stategraph start end.
Import stategraph, start, and end from the LangGraph graph module. Stategraph is a class for constructing stateful workflow graphs, while start and end are special markers used to define the entry and exit points of the graph.
From LangGraph, types import command interrupt.
Imports the command, class, and interrupt function from LangGraph's types module, providing tools for pausing graph execution and resuming with external input.
Class agent state typed dict.
Defines a type named agent state using typed dict, which creates a dictionary-like structure with type hints for each key. This establishes a schema for state data that will be used within the LangGraph system, ensuring type safety and clarity for state management.
At tool, def send email to, SDR subject, SDR body, SDR. Send an email to a recipient.
Defines a function, send email, decorated with @tool, indicating it's a tool function that can be used within a LangGraph workflow. The function takes 3 string parameters: to recipient, subject, and body email content. The docstring specifies its purpose is to send an email to a recipient.
Response equals interrupt.
Calls the interrupt function to pause graph execution at this point, passing an object likely containing JSON serializable data that will be returned to the caller in the interrupt field. This triggers LangGraph to save the current graph state and wait for external input before continuing.
Action, send email.
Specifies an action of type send email in what appears to be a configuration or command structure. This line sets the action field to the string value send email, indicating that the intended operation is to send an email. The exact context and how this action is processed would depend on the surrounding code or framework, but this line itself simply assigns the action identifier.
To.
Assigns the value of the variable to a key named to in a dictionary or object literal. This creates a key-value pair where the key is the string to, and the value is whatever is stored in the variable to. The line itself doesn't perform any computation or transformation. It simply maps the existing variable to a named field in the structure being constructed.
Subject.
Passes the subject variable as a named parameter in a function call or dictionary construction. The line demonstrates parameter assignment, where subject is being explicitly mapped to its corresponding key in the target structure.
Body.
Assigns the value of the body variable to a key named body in what appears to be a dictionary or JSON-like structure. This line is likely part of constructing a data payload, where the body content is being explicitly included under its own key, possibly for transmission or storage. The observable effect is that the body variable's value becomes accessible via the body key in the containing structure.
Message. Approve sending this email.
Creates a message string with the value approve sending this email. That will be displayed to request user confirmation before proceeding with email transmission.
If response, get action == approve.
Checks if the response dictionary contains a key, action, with the value approve. This conditional evaluates to true only when the response explicitly indicates an approval action, allowing the code to proceed with approval-specific logic in the subsequent block. The check uses the dictionary's get method to safely access the action key without raising a key error if the key doesn't exist.
Final to = response, get to.
Retrieves the value associated with the key to from the response dictionary, and if that key doesn't exist, defaults to the value of the variable to. The result is assigned to the variable final to. This is a common Python pattern using the dictionary get method with a default value.
Final subject = response, get subject.
Retrieves the value associated with the key subject from the response dictionary, and if the key doesn't exist, defaults to the value of the subject variable, then assigns the result to final subject.
Final body = response, get body.
Retrieves the value associated with the key body from the response dictionary, and if that key doesn't exist, defaults to the value of the body variable. The result is assigned to final body. This is a common pattern for safely accessing dictionary values with a fallback.
Print send email to = final to subject = final subject body = final body.
Prints a formatted debug message showing the email parameters being processed, including the recipient address, final to, subject line, final subject, and email body content, final body. The output follows the pattern send email to equals, subject equals, body equals, for logging or monitoring purposes.
Return F, email sent to final to.
Returns a formatted string indicating successful email delivery to the recipient stored in the final to variable. The string follows the pattern email sent to recipient, where recipient is replaced by the value of final to. This serves as a simple confirmation message that would typically be displayed to the user or logged after an email operation completes.
Return, email canceled by user.
Returns the string email canceled by user as the output of the current function or execution path. This indicates the operation was terminated by user action. likely surfacing as an interrupt payload in the interrupt field when the graph execution is paused for external input.
Model equals chat Anthropic model equals Claude Sonnet 4-5-20,250,929. Bind tools send email.
Creates a Chatanthropic model instance using the Claude Sonnet 4520250,929 model and binds it to a tool called Send Email. This configures the model to have access to the email sending functionality when generating responses.
Def agent node state, agent state.
Defines a function named agent node that accepts a single parameter, state, of type agent state. This establishes a node function signature for use within a LangGraph workflow, where the function will process the graph's current state when executed.
Result equals model. Invoke state messages.
Invokes the model with the messages from the current state, passing the messages array as input to generate a response. The result of this model invocation is stored in the result variable for subsequent processing. This is a synchronous call that executes the model's logic on the provided messages and returns the output.
Return messages, state messages, plus result.
Returns a dictionary with a messages key containing the current state's messages array concatenated with a new result message. This effectively appends the result to the existing message history while preserving all previous messages in the state.
Builder equals state graph agent state.
Creates a state graph instance using agent state as the state type. This initializes a graph structure that will manage state transitions and execution flow, with agent state defining the shape and behavior of the state object that will be passed between nodes during graph execution.
Builder, add node agent, agent node.
Adds a node named agent to the graph builder, where agent node represents the node's implementation or configuration. This registers the node in the graph structure, making it available for connections and execution flow. The node can later be referenced by its identifier, agent, when defining edges or dependencies.
Builder at edge start, agent.
Adds a directed edge from the start node to the agent node in the graph being constructed by the builder. This establishes that execution should flow from the starting point to the node named agent when the graph runs.
Builder, add edge agent end.
Adds a directed edge from the agent node to the end node in the graph, establishing a transition path that terminates the graph execution when reaching the agent node. This creates a simple linear flow where the graph completes after processing the agent node.
Checkpointer equals SQLite SQLite 3. Connect tool approval, DB.
Creates a SQLite saver instance named checkpointer that connects to a SQLite database file named toolapproval, DB. This instance will handle persistence operations for saving and loading graph execution states, using the provided database connection for storage.
Graph equals builder. Compile checkpointer equals checkpointer.
Compiles the graph builder into an executable graph instance, passing the specified checkpointer to enable state persistence and interrupt handling. The resulting graph object can now be invoked with configurable thread IDs to manage execution's state across interruptions.
Config, configurable, threaded, email workflow.
Creates a configuration dictionary with a nested, configurable key that sets the threaded to email workflow. This threaded acts as a persistent cursor for LangGraph's interrupt mechanism, allowing the system to identify and resume the specific execution state associated with this workflow.
Initial equals graph invoke.
Invokes the graph execution and assigns the result to the variable initial. This triggers the graph's processing pipeline with any configured parameters, potentially starting a new execution thread or resuming an interrupted one based on the current state. The invoke method initiates the graph's workflow and returns the output, which could include an interrupt payload if execution was paused for external input.
Role, user, content. Send an email to email protected about the meeting.
Creates a user message object with role, user, and content instructing to send an email to a specified address about a meeting. This represents a standard input format for LangGraph, where the message will be processed by the graph execution system.
Config equals config.
Passes the config parameter to a function or constructor, likely configuring interrupt behavior in LangGraph by specifying thread persistence and checkpointing settings. The config object typically contains configurable properties like threaded to manage execution state and resuming interrupted workflows.
Print initial interrupt hash interruptful equals action. Send email.
Prints the value stored in the interrupt key of the initial dictionary, which contains an interrupt object with an action payload indicating a request to send an email. The output shows the interrupt was triggered with a specific action and associated data, surfacing the payload that the graph is waiting to resume.
Resumed equals graph invoke.
Invokes the graph execution and assigns the result to the resumed variable. This call triggers the graph's processing pipeline, which may include handling interrupts if they were previously triggered. The invoke method initiates the graph's workflow, potentially resuming from a saved state if an interrupt had paused execution earlier. The returned value, stored in resumed, contains the output of the graph execution, which could include an interrupt field if the graph is waiting for external input.
Command resume equals action. Approve, subject, updated subject.
Creates a command object that resumes a paused LangGraph execution with an approval action and an updated subject. The resume parameter contains a dictionary specifying action as approve and subject as updated subject, which will be passed back to the interrupted node to continue execution with this external input.
Print resumed. Messages -1 hash tool result returned by send email.
Prints the last message from the resumed dictionary's messages list, which contains the tool result returned by the send email operation. This implementation demonstrates LangGraph's interrupt-driven workflow pattern, where execution pauses at critical points to enable human-in-the-loop validation. The core mechanism combines three key components: the interrupt function that pauses execution and surfaces payloads in the interrupt field SQLite checkpointing via SQLite saver that persists state between interruptions, and thread-specific identifiers that maintain execution context across suspension boundaries. The send email tool showcases how to instrument sensitive operations with approval logic. By calling interrupt before sending, it creates a bidirectional communication channel where the payload containing email details becomes available for external review. When resumed with command resume equals, the tool either executes with original or modified parameters or cancels entirely based on the response. This pattern is particularly valuable for operations requiring human oversight, though it introduces complexity in managing side effects since nodes restart from the beginning when resumed. The design choice to place interrupts within tools rather than nodes makes the approval logic reusable across different graph structures. The threaded acts as a persistent cursor, allowing the system to identify and resume specific execution states. This creates a flexible approval system that maintains safety through explicit human confirmation while enabling durable workflows where approvals can happen asynchronously. The implementation effectively balances automation with human oversight, demonstrating how LangGraph's interrupt mechanism can be leveraged to build secure, human-in-the-loop workflows.
The interrupt vanishes into the void, yet the checkpoint clings to the thread like a barnacle on a ghost ship.